The ratio 1 is to 1.5 by 3, no, it is by weight, is used in a concrete mix. And we're given here data, cement, 50 kg bag yung ginamit natin with specific gravity of 3.15. So clarify ko muna guys ha. May dalawang variant tayo ng size ng bag ng semento, no? We have the 40 kg and then we have the 50 kg. Well, actually guys, no, sa Philippines, yung common na nakikita po natin, that is actually a 40 kg na bag, okay? Na nakikita normally sa mga small construction, no? So, in our problem solving, in case hindi binigay, most likely 40 kg po yung pinapagamit yan. Unless mag-specify sila like this one, no? Na we use 50 kg, okay? Then we have the sand, specific gravity is 2.2, then gravel, specific gravity is 2.7. Then binigyan tayo dito, water 20 liters per bag of cement. So our first question is, determine the volume of cement used for a bag of cement. So, sa isang bag of cement daw, ano daw yung volume na nagamit natin sa isang semento? Okay? So, to tackle this, no, we need to go back yung concept natin sa ating hydraulics at geotechnical engineering, no? Yung ating unit weight. Okay, or gamma natin, no? So, yung unit weight, paano ba natin siya kinukuha? Diba we obtain this by having the weight of the material over the volume of the material, diba? So, if you want to get the volume, anong gagawin mo? That would be volume is equal to weight over gamma. Okay? So, ngayon guys, anong weight, anong volume ba yung tinutukoy nito sa problem natin? Okay? So, actually guys, no, as early as now, kwento ko na, ang volume na tinutukoy po dyan guys, is yung volume ng ating semento na imagine it na walang voids, okay? Kasi guys, we will get the volume here. Sa ating gamma sa baba, we will be using our specific gravity. Diba? Yung gamma natin, no, ng material natin, if we have its specific gravity, i-multiply mo yan ng gamma water, ano mangyari? Kasi you'll get this one, yung gamma ng material. So that's what we will do here, no? Gamma water. So ano ba significance nito guys? No? Ano mang meaning dyan? Sinabi ko na volume na walang voids. Sige guys, I'll give you an example doon sa ating geotechnical engineering, no? For example, ito yung ating soil block, no? And then, let's say na naka-dry state tayo. Di ba we have a gamma dry for that, okay? Let's say na we have specific gravity here, or GS yun sa geotechnical engineering. Now, matanong ko guys, if you have specific gravity sa lupa natin, if you multiply this by gamma water, ano makukuha mo? Okay? Makukuha mo ba yung gamma dry? Yes or no? Well, the answer is no, okay? Kasi guys, yung specific gravity ng lupa natin, ang tinutukoy po dyan, no? Pag i-zoom in natin to, zoom in natin yung particle ng lupa, that would be the specific gravity of this soil particle mismo, okay? So, yung material mismo, yung particle mismo. So, meaning, if you do this, you will get a unit weight of this material, no? So, ano ba pinagkaiba ng unit weight na yan to your gamma dry? Yung gamma dry guys, no, sa ating geotechnical engineering, kino-consider po natin dyan yung ating voids sa ating lupa. Again, I call gamma or unit weight, that is weight over volume. So pag meron kang voids, nakaka-apekto po yan sa ating volume. Okay? So pag ginawa mo to, you'll be getting a unit weight of that material, no, assuming na walang voids. For example, meron kang unit weight ng steel. Okay? Ang assumption sa unit weight ng steel, you have a weight of that steel material, then ang volume niya solid yan, walang voids yan, no, sa volume na yan. Okay? Same idea sa ating ginagawa po dito, no? Okay? You'll be getting a gamma here, no, assuming na wala po talaga yung voids. Therefore, when you operate this one, no, when you operate this one here, you will get a volume na solid, no, yung walang voids, no, yung volume mismo ng material. Okay? Now let me ask you, bakit na natin ginagawa yan? Kasi guys, no, if you think about it, for example, ito yung ating cement na block, no? Let's say ito yung ating cement particles. So diba sa ating cement particles, of course, no, kahit pino yan, pag i-zoom in mo yan, okay? Zoom in natin. Ito yung particles natin. Still, meron pa rin tayong voids dyan in between, no? Okay? Same thing sa ating sand, okay? Yung sand po natin, guys, pag i-zoom in mo yan, same thing, may voids din yan. Mas lalo na yung gravel, diba? Yung gravel, kitang-kita yung mga voids, no? So when you mix that component, no, cement, sand, gravel, ano mangyayari? Yung voids ng ating gravel, i-fill ko yan ng ating sand. Then yung voids ng sand, i-fill ng ating cement. Then yung voids ng cement, dyan papasok yung ating tubig. Okay? So ano mangyari? You will get a compact no na volume. And that's the reason when we do this, we want our volume to be yung solid na volume, no, yung walang voids. Okay? Yan po yung goal natin dito no, when we're conducting this one here. Okay? So I hope to explain ko na maayos yung ating concept here. So now let's answer number 1. Determine the volume of cement used for a bag of cement. Okay? So volume, that would be weight over the unit weight of the material, or that would be weight times specific gravity times gamma water. Okay, so ano man yung weight natin guys? Diba sinabi sa problem, ano daw yung volume ng cement natin used for a bag of cement? So isang bag of cement lang. So ano yung one bag of cement natin sinabi? Diba sinabi dito we have a 50 kg per bag. So may weight tayo. Or technically mass pa yan, no? We have here 50 kg mass. So it's okay, no? Kahit hindi ka mag-weight dito guys, mag-mass ka lang. As long as yung unit weight mo sa baba ng water, you make it as density, okay? Kasi density na kilograms yan, no? Is kilograms man yan, okay lang, mag-cancel lang yan, okay? Then we have specific gravity ng cement, we have here 3.15. Then gamma ng water, or the density of water, kasi we use kilograms, no? So that's 1,000 kilograms per cubic meter. So you'll notice guys, no? Yung kilograms mag-cancel, diba? Itong over cubic meter malilipat din sa taas. So there you go, you get a volume, no? Nasagot. So sige guys, no, let's operate this. 50 over 3.15 times 1,000. Okay, so you will get here 0.0158, or let's round it up to 3 decimal digits lang, 16, okay? Cubic meter. So ito po yung sagot natin guys for number 1. So that would be letter B. Okay? Sige, no, let's store this to variable A. Sige, proceed tayo next item. Determine the volume of sand used for a bag of cement. Same concept din guys, no? That is volume is equal to weight over gamma ng material, or that is weight over specific gravity times your gamma water. So ano man yung weight ng ating sand? May binigay ba? Well, of course, walang binigay yung weight ng sand sa ating problem. Pero, alam natin na sa isang bag of sand natin, or isang bag of cement na gamitin, di ba? And then we know that the ratio is 1 is to 1.5 is to 3 by weight. Okay? So kanina, if you recall, di ba we use a weight na 50 kilograms. Therefore, pagdating sa sand, since ang ratio natin 1 is to 1.5, dapat yung ating weight ng sand is 1.5 of 50 kilograms. Okay? Klaro po ba yan? Kasi nga we're using this ratio 1 is to 1.5 is to 3. Okay? Then sa baba, we have the specific gravity ng sun, we have 2.2. Then gamma ng water, again supposedly gamma ng water yan, but sa taas instead of weight, we use mass na kilograms. So therefore, yung gamma ng water, we will use here density, which is 1,000 kg per cubic meter. So makancel yung PD cancel, you'll have your cubic meter na unit, no? Sige, let's operate this. 50 times 1.5, then you have 2.2 times 1,000. There you go. You will get 0.034 cubic meter. Okay? So, ito po yung sagot natin guys, number 2, and that would be letter C. Okay? So, sige no, pa-store lang to sa ating variable D. Sige, let's proceed next item. Determine the volume of gravel used for a bag of cement. So, same process guys, no? You have volume is equal to weight over the gamma of the material, or that is weight over specific gravity times gamma water. And again, no? Ang ginamit natin kanina, isang bag of cement, no? Since ang ratio natin 1 is to 1.5 is to 3, yung 3 na part dito is yung ratio sa ating cement at gravel, no? 1 is to 3. So, therefore, kung 50 kg yung isang bag, ito times 3 para sa gravel. Then, specific gravity natin, we have 2.7. Then, gamma ng water, and again, we use kilograms, so therefore, we use density. 1,000 kilograms per cubic meter. Okay, so let's operate this. We have 50 times 3 over 2.7 times 1,000. There you go. You will get 0.056, okay, cubic meter. So, ito po yung sagot natin, guys, for number 3. That is letter A. Okay? Pa-store na lang po ito sa ating variable C. The next item tayo. Determine the total volume of concrete per bag of cement. So, tanong sa atin guys, no? Sa isang sako na semento, okay? Ano yung makreate natin na volume of concrete? So, yung volume of concrete, ano man ito compose of? Diba compose of yan ng, well, of course, cement. Next is sand, next is gravel. Then you have, of course, yung tubig. Of course, we need the water na hindi po mag-mix ng pag walang tubig. And supposedly, if this is a theoretical approach, may air, kasama na trap air. Pero sa ating proportioning na method, yung itong by weight by volume, no, yung air gas na we neglect this part here. Okay? So, ito lang muna. So, we got this cement no, sa ating number 1, ito number 2, number 3. So, right now, to answer number 4 for the total volume, we need to get first the volume ng water. So, ano sabi sa problem? Di ba, nasabi niya dito that for water, we will use 20 liters per bag of cement. Okay? So, therefore, if 20 liters yan, ano man yan sa cubic meter? Di ba we know that 1,000 liters equal to 1 cubic meter na conversion natin. So, this would become 0.02 cubic meter na tubig. Okay? So, after having that, we can calculate for our total na volume ng concrete for 1 bag of cement. Okay? So, ano nga yun? That is yung nakastore sa variable A, yung cement natin for 1 bag of cement. Si variable B, yung volume ng sand natin for 1 bag of cement. And lastly, C, yung nakastore kay gravel, no? Yung nakastore natin yung gravel na dyan. And then lastly, you have the water na 0.02 cubic meter. Okay? So, sige na, let's operate this. A plus B plus C plus 0.02. Okay, there you go. You will get 0.1255, or let's round it up, no? Kasi 5 yung next na decimal, so you have 1.126 cubic meter. Okay, so this would be your answer for number 4, that is letter C. Now, for the last item for this situation, ang tanong sa atin is, determine the approximate number of bags of cement for a 25 cubic meter concrete member. So, may structural member tayo na ito yung na-estimate na volume kailangan, 25 cubic meters. So, tanong sa atin, ilang bags of cement na gagamitin natin? Di ba na-calculate natin kanina that we will have, no, 0.126 cubic meters of concrete per 1 bag of cement. Di ba? Kasi yung tinumpute natin kanina, guys, from number 1 to number 4, volume po yun ng concrete, no, for 1 bag of cement. So, ngayon, if meron kang total volume, anong gagawin mo? So, diba ito naka-cubic meter to? Ang gusto mo malaman ilang bags of cement meron. So, ang gawin mo lang, of course, that would be 25 cubic meter. I-divide mo dyan yung 0.126 cubic meter per bag of cement. By doing this, no, cancel yung cubic meter and you will get the number of bags of cement. So, let's operate this. You have 25 over 0.126. So, dyan, no, you will get here 198.4 bags. Well, of course, no, when you order doon sa ating hardware, hindi man pwedeng umorder ka ng 198.4. Wala akong ganun, no. So, you might order here, no, 199 bags. Okay? And actually, no, sa ating actual construction, nagpapasobra pa nga tayo dyan, no. Usually, no, around 5 to 10%, no, depende sa material, kano siya ka easily ma-waste, no. So, I think 5% is good enough, no, for a small project. So, that would be your answer, 199 bags. That would be letter A. Situation number 2. A certain structural member is to be poured with 30 cubic feet of concrete using a proportion 1:2:3 by volume. So, recall this kanina, sa ating previous situation, we have there a proportioning na by weight. Okay, so bali yung pag-ratio natin timbang yung ginagamit. Right now, we will be using by volume. Okay? Water cement ratio is 0.7 by volume. Okay, so we have ratio ng semento at tubig, 0.7 daw, pero by volume. Kasi guys, we also have water cement ratio by weight. So, take note lang din ha. Then we have here the specific gravity of the material, then the unit weight. The number 6, find the approximate number of bags of cement. So, ito muna guys, matanong ko muna. Sir, by volume man to, di ba? Then we have the total volume target. Pwede ko ba yung gawin dito, sir? Since 1:2:3 yung ratio natin, no, let's say, no, x is the amount needed or sa ating cement, then you have your added 2x for the sand, then 3x sa ating gravel equal to 30. Can I do this, sir? Okay, so let's try to solve this. Malabas dyan, okay? Out of curiosity. Equal to 30. Okay, now you will get your x is equal to 5. So, na ibig sabihin nito, is it correct to say na I will use 5 cubic feet para sa aking cement, then I'll use 10 cubic feet para sa aking sand, then I have 15 cubic feet para sa aking gravel. Say, sir, if I add this up, I will get 30. Okay? So, some of you might think, sir, hindi pa kasi may tubig. Well, actually, no, let's stop na no, from there kasi from the start pa lang, mali po to. Okay, you cannot do it like this. Okay, hindi po to parang algebra problem na ganyan lang ginagawa, no. Kasi guys, when you have this volume ng cement natin no 1, again, recall ko, that cement volume, may voids po yan. When you add it sa ating sand na volume, of course, may voids din yung sand. So, technically, itong volume na to, sabihin natin volume x yan. Pag i-add mo yan dyan, okay, say 2x ginawa mo, hindi po yung mag-equal to 3x kasi nga, yung mga parts na yan, papasok po yan doon sa mga voids. Okay? Nagets po ba yun? Okay? For example, ito. Let's say meron akong container na merong mga bato. Then meron akong tubig, let's say, no, sabihin kong 1/4 depth sa ating same container. Ngayon, di ba right now, ang volume natin dito, isang container yan, no, yung occupy ng mga bato dito, sa kabila, we have 1/4 na tubig. Okay? Ngayon, if I add this water dito sa mga bato, ano yung magiging outcome natin ng volume? Well, actually, yung lalabas din dyan, is just isang container din, no. Kasi malamang yung ating tubig, hindi yan napuno siguro, no. Let's say, nandiyan lang yung tubig, no. It seeps through doon sa voids ng mga bato natin. Okay? So it's wrong to say na pag inad mo tong dalawa, you will get 1.25 or 1 1/4. Okay? That's why hindi ko gagana yung technique na ganyan, no? Kasi nga, yung ating maliliit na particles, doon papasok sa mga butas, doon sa mga malaking particles. Okay? So yan po yung ibig ko sabihin kanina sa ating previous situation. That's why we are getting their volume in which yung compact po siya, no? Kaya nag-gets po yun? So sige, no? Ang gagawin natin dito, guys, is first let's obtain muna yung volume na i-occupy per component natin, no? Anong volume i-occupy ni cement, ni sand, ni gravel. Okay? Sa isang bag of cement, no? Para meron tayong basis later on. So let's start with our cement. Okay? So volume cement. Ano ang ginagawa natin kanina? Diba, what we do is, to get that volume, that would be weight over gamma. Diba? And then yung ating gamma, ang ginagamit natin dyan is yung specific gravity times gamma water. So that, ang makukuha natin ng this unit weight kasi, ang idea dito is wala itong voids, diba? Okay? Yung unit weight na lalabas is yung specific gravity. So that's why makukuha mong volume is yung volume na walang voids. Okay? Yung solid ba? Yung puro. Okay? So let's do that. So we have there sa taas ng weight. So saan mo tayo kukuha ng weight ngayon? So mag-iisip kasi, saglit lang. If that is weight over gamma, sir, meron naman akong unit weight dito. So wala na ba itong silbing specific gravity na yan? Well, the answer is no. Again guys ha, sa denominator, we will be using the SG times gamma water. No, we will use this one, no, specific gravity. So sir, para saan mo yung unit weight na yan? Again, when you do the SG gamma water, ito lalabas, diba? And this unit weight, again, ulit-ulitin ko na, para ma-absorb na talaga, hanggang magsawa kayo sa akin, is yung weight mo over volume na solid. Okay? Itong binigay ng mga unit weight dito guys, hindi po yan mga solid na volume. Okay? May weight ka ng cement over a volume ng cement na may mga voids. Same sa sand, no? Yung sand mo may voids, din yung gravel may voids din. Ito yung mga unit weight na yun, this one here. Okay? So para saan yan sila? You will use this unit weight here na column to get your weight. Kasi guys, no, if you have this, then you have the volume na may voids, yun na, may weight ka na. So ano naman yung volume yan, sir? So balik tayo ngayon sa ating assumption ng ating isang bag of cement. Okay? A good assumption for this guys, no, in English unit system is one bag of cement natin, this constitute to approximately 1 cubic feet of volume. Okay? So, if you have here a unit weight na naka-pounds per cubic feet, if you multiply it by this, ano makukuha mo? You will get naka-pounds, no? Or that is naka-weight, di ba? So that will be the weight we will be using sa ating numerator. Okay, na-follow po ba yun? And in the SG, you will use this again doon sa ating denominator. Okay? So, let's do that. So, let's start with the cement. We have here 94 pounds per cubic feet. Okay? And anong volume natin? Again, we're getting here muna per 1 bag of cement. Okay? 1 bag muna. So, yung 1 bag approximately 1 cubic feet po yan, no? And then, sa baba, you have specific gravity which is 3.15. And then, gamma water. So, be careful ha. Huwag po tayong gumamit ng 9.81. Kasi no, sa ating bansa, no, we are used in using the metric system, no? So, sa English, yung water na unit weight, that would be 62.4 pounds per cubic feet. When you multiply this, no, when you operate this, cancel ito, ano makikira? You'll have in cubic feet, diba? So, that's in volume. So, let's calculate that. We have here 94, then times 1. So, kita natin times 1. And then you have here 3.15 times your specific gravity, and then times unit weight ng water, 62.4. You will get here 0.478 cubic feet. Okay? Let's store this sa variable A, guys, no? Next, kuha tayo ng volume ng sand sa isang bag of cement. Okay? So, unit weight ng ating sand, we have 110 pounds per cubic feet. And then, ano man yung volume natin? Again, no, if you want to get the weight, that would be gamma na ito times the volume na may voids. Since ang ratio natin 1 is to 2 is to 3, okay, dapat times 2 sa ginawa natin sa cement. So, since nag 1 bag muna tayo, therefore, sa sand natin, dalawang bagay or 2 cubic feet po yan. Okay? Then sa baba, we have here the specific gravity, 2.4, and then gamma ng water, 62.4. Again, no, makancel yung mga units dyan, matitira dyan is yung cubic feet. So, let's operate this. 110 times 2 over 2.4 times 62.4. You will get here 1.469 cubic feet. Pastor na lang po ako kay variable B. The next tayo, volume ng gravel, no, or coarse aggregate. So same concept, no? Unit weight niya, you have there 100 pounds per cubic feet. And then you have anong volume natin? So 1 is to 2 is to 3, so 3 gagamitin natin ng 3 cubic feet. And then the specific gravity, you have 2.7, and then gamma ng water, 62.4 pounds per cubic feet. Okay, so operate mo yan, no? Cancel itong mga units, you will be left with cubic feet, no? So sige, calculate natin. You have 100 times 3 over 2.7 times 62.4. You will get 1.781. So round it off natin ito, no? Kasi 0.6 yan, so magiging 1 na yan. So that would be nakastore sa variable C. Ayan. So right now, we have the volume ng cement, sand, and gravel for a 1 bag of cement natin. Pero guys, no, when we do concrete mix, of course, may tubig pa yan. So, ano sabi sa problem? We have a water-cement ratio, 0.7 by volume. So, water-cement ratio. So, that is volume ng water over volume ng cement. Diba? And then the value of this is 0.7 daw. So, therefore, if you want to get the volume of water, anong gagawin mo? That would be 0.7 times volume of cement. So, anong volume ng cement po natin? So, be careful ha, yung volume cement tinutukoy po dito na sa water-cement ratio. That is from this proportioning na 1, 2, 3. No? So, itong volume po yan, this part here. Ito po yung volume na, no, meron pa siyang voids, no, this one here. So, that would be times your 1 cubic feet. No, yung ginamit natin kanina, this one here. The 1 cubic feet. Okay? So, ang lalabas po dito, 0.7 times 1, of course, that would be 0.7 cubic feet. So, let's store this to variable B. Ayan. So, right now, lahat ng component ng ating concrete mixture na store natin sa calculator. So, right now, let's get the volume of concrete sa isang 1 bag of cement. Okay? So, that would be nakastore sa A, nakastore sa B, nakastore sa C, at D. I-add natin yung 4. So, A, B, C, and D. You will get a volume of 4.428 cubic feet. Okay? So, yan po yung volume natin sa isang bag of cement, no? Ito yung volume ng concrete na magagawa natin sa isang bag of cement following the proportioning na 1 is to 2 is to 3 by volume. Okay? So, after having this, ang tanong sa atin, find the approximate number of bags of cement. So, di ba ang gagawin natin? 30 cubic feet. We have here 4.42 cubic feet per bag of cement. Therefore, if you want to know the number of pieces ng ating bags, ano ang gagawin natin? That would be 30 cubic feet divided by 4.428 cubic feet per bag of cement. Di ba? So, cancel yung cubic feet, matitira sa'yo yung number of bags. Okay? So, sino-operate natin to? That would be 30 minus yung answers calculator. So, you will get here 6.77, or of course, no, walang 6.77 na bag. Round off natin yan, gawin natin 7 bags. Okay? So, this would be your answer for number 6, no, letter C. Find the approximate volume of sand required in cubic feet. So, kanina, we have the number of bags of sand, 7 yun. Okay? And ngayon, volume ng sand required in cubic feet. Again, no, recall ko lang na yung volume proportioning natin is 1:2:3. Okay? So if that's the case, if meron akong 7 bags na semento which constitute to approximately 7 cubic feet, therefore, ang sand na gagamitin ko ngayon, that would be, of course, malamang 14 cubic feet kasi 1:2 po yan. Okay? So you'll be answering letter C, no? Very easy. Easy breezy. Okay, may wonder, sir, saglit lang. Sabi mo, sir, kanina bawal tayo mag-ratio ng ganyan kasi iba yung volume. Again, guys, yung volume na tutukoy po kanina is getting the volume ng ating concrete, no? Anong volume ng concrete na magagawa natin sa isang bag ng semento, sa isang bag ng cement. Kasi nga, yung sabi ko, mag-overlap yung sa semento, sa sand, sa gravel. Okay? Pero after magawa mo yun, malaman mo yung number of bags na, still, that bags na meron ka, itong proportion na meron tayo dito, ginawa yung proportion na yan using a volume na merong voids. So if merong voids pala naman yan, okay, therefore, when you do the ratio proportioning, no, if 7 bags na may voids, therefore, you can use the 14 cubic feet ng sand na may voids rin. Okay? Kasi guys, it's very difficult to measure a volume ng sand na walang voids. Kukumpa ko pa yan before mo ihalo sa mixture. Kasi yun, di ba? So therefore, we want this proportioning here na pwede mong gawin, ipasok mo lang sa sako ng semento. For example, yung 1 sack of sand. Pasok mo sa 1 bagger mixer. Then kuha ka 2 sako ng buhangin. Pasok mo sa 1 bagger mixer. So you can do that. That's practical enough. So let's find the proportioning here na 1:2:3. That is volume. Ito mga volume yan na merong voids. But again, remind ko lang, when we calculate the volume of concrete here, we are getting the volume of concrete here, yung mga parts na to na wala mo ng voids. Kasi we want it to sit doon sa mga voids nila. Okay? I hope na get ko yun, no? Sige na, that would be your answer, letter C for number 7. Proceed to number 8. Find the approximate volume of coarse aggregates. Of course, no, 1:2:3, 7 yung cement, 3 yung ating, times 3 yung ating coarse aggregate. Therefore, sagot mo dito, that's letter B, 21. So, kita natin, 1:3, 7, malamang, this is 21. Okay? So, proceed to number 9. Find the approximate volume of water in cubic feet. Again, the water-cement ratio, we have here 0.7. Okay? Volume water, volume cement, that's 0.7. So, volume of water, and we use here, anong volume ng cement? We use 7 cubic feet. Diba? So, if you multiply that, you will get 4.9 cubic feet of water. So, that would be letter B. Okay, so yun lang po guys, no? Actually, the concept is very basic man, no? The proportioning ka, you have 2 options. You do the proportioning by weight or you do it by volume. Okay? So, actually guys, napakita natin sa equation 1 and 2. Itong method na to, again, ulitin ko, these are just approximation, no? Para mapadali yung mga small projects natin. But in reality, if we conduct a thorough na concrete mix, no? Iba po yung procedure dyan. And actually, yan po yung binigay ng examiner last November 2018. So, we will tackle that in our next situation. Situation number 3, this is the seaboard November 2018. No? The basic data for proportioning trial batches for normal weight concrete with an average compressive strength of 35 MPa at 28 days are as follows. Meron tayong slump, then we have the water cement ratio, and then be careful, yung cement ratio natin dito is by weight. And then you have specific gravity of cement, specific gravity of coarse aggregate and fine aggregate. Then we have the water, which is the net mixing, 180 kg per cubic meters. We have entrap air na 1% in the unit of concrete used 23.6. Question number 10. What is the total solid volume of water, cement, coarse aggregate, and entrap air if the dry weight of coarse aggregate is 10.1 kN per cubic meter? So guys, ang tinatanong sa atin is yung total volume ng tubig, semento, gravel, and then entrap air. So right now, wala mo ng part yung sa sand natin, hindi pa tinatanong. Kasi guys, actually, yung ginawa ng examiner dito, she is just guiding us sa anong procedure dapat when we're doing a thorough na ACI method of proportioning. Now, actually, guys, this ACI method, ang process po dito is first kuha ka muna ng volume ng ating cement. Okay? After makuha yung volume ng cement, I'm sorry guys, nauna pala volume of water. Okay? Tubig muna, then you have water of cement, volume of cement, and after that, volume of your coarse aggregate. Then after that, you get the volume of your entrap air. Pag makuha mo na yung apat na yan, i-add mo na yan sila lahat. Okay, let's call it volume B. Pag makuha mo na yung volume B na yan, ang goal mo kasi dito guys is you must create a 1 cubic na concrete. Pag i-add mo ito lahat dito, you will get a value man, di ba? Anong kulang dyan para maging 1 cubic meter yung ating concrete? Yan po yung part ng ating sand. Okay na? Ano yung kulang dito? That would be your fine aggregate na volume para maging 1 cubic meter volume of concrete yung magagawa natin. Ganito po yung procedure dito sa ating ACI method. No, again, ulitin ko ha. First, secure your data sa volume ng water, ng cement, coarse aggregate, and voids, no, or yung ating, entrap air. I-add mo yan lahat, you'll have, let's call it volume B, and then anong kulang sa volume B para maging 1 cubic meter? That would be the part ng ating fine aggregate. Okay? So sige no, let's start with our volume ng water. Dito natin sulat lang, para diretso. Volume ng water na binigay sa atin. Bigay sa ating data ng water dito, this one. Okay, we're given here water net mixing, 180 kg per cubic meter. You might wonder, sir, itong 180 kg per cubic meter, is this density? So, good question no, kasi you notice the unit dito, naka-kilogram per cubic meter. Is it density? Paano ba density ng water normally? Diba that's 1,000 kilograms per cubic meter? So, ano itong 180 dyan, sir? Ano man yan? Ay po ba yan? Actually, hindi. That 180 kilograms, ang ibig sabihin dyan, sa ating 1 cubic meter na concrete batch, okay, ng concrete, no? We will be using 180 kilograms of water. So yan po yung ibig sabihin sa given na yan guys. Ito yung 1 cubic natin, ito yung tubig natin. No? And this is 180 kilograms sa isang cubic meter na concrete. Yan yung ibig sabihin dyan, hindi po yung density. So right now, diba meron na tayong water na 180 kilograms. So ano man yung volume natin dyan? Diba ang ating water guys, if you recall it, it is safe to say na 1 kilogram of water is 1 liter of water. Diba? That is a good approximation. No? Isang kilogram ng tubig, yung pure water that is equivalent 1 liter of tubig rin. So therefore, if I have 180 kilograms, that also constitute, it will occupy a volume of 180 liters. So this is 180 liters yung ating volume ng water, or in cubic meter, that would be 0.18. Next, let's get naman yung ating volume cement. So, paano natin kunin yung volume cement? Makukuha mo yan using the water-cement ratio. Okay, so be careful guys ha. Huwag mo i-ratio agad itong 0.18 na cubic meter na yan kasi volume yan. Ang ating ratio dito is by weight. So be careful, no? Mag-ingat po tayo dyan. Maraming nagdali dyan no, sa board exam. So we have here weight ng ating water over weight ng ating cement equal to 0.48. Ano naman yung weight ng water natin? Di ba given tayo no, 180 kg sa isang cubic meters. Ano naman yung ating ratio? We have 0.48. Therefore, masosolve na natin itong weight ng cement. So that would be weight ng cement equal to weight ng water, which is 180 kilograms over 0.48. Sige na, operate natin to. 180 over 0.48. You will get 375 kilograms. Sa cement, 375. Ngayon, yan po ba yung ipapasok ko dito sa ating volume cement? Well, the answer is no, kasi 375 kilograms po yan. No, weight po yan ng semento natin sa isang cubic meter na concrete. So, we need to convert that. And again, how do we convert that into volume? Again, balik po tayo doon sa ating ginagawa sa ating previous situation. Di ba, ano ngayon? What we did is volume is equal to weight over gamma, in which yung gamma natin dapat manggagaling sa specific gravity times gamma water para solid po yung volume dyan. So, yung weight natin na we have here, weight ng cement, we have 375 kilograms over specific gravity ng cement. Given po yan, you have here 3.15. And then you have gamma ng water. Since kilograms ang ginamit natin, we must use density. 1,000 kilograms per cubic meter. You operate that, cancel po yung kilograms, matitira is volume. Sige na, operate natin. You have 375, yung sagot ko rin sa calculator, over 3.15 times 1,000. You will get 0.119 cubic meter. Okay, now let's underline this. It's important ito. That would be the volume ng ating cement. 0.119. The next volume ng ating porous aggregate. So to get that volume, again, balik tayo doon sa concept na ginawa natin, no? Which is volume ng ating material, in this case, the porous aggregate, that would be weight ng material over gamma ng material. So anong weight ng ating porous aggregate? So sir, wala mang binigay. So if you look at our number 10 guys, no, na question, may dry weight po siyang binigay. Dry weight course aggregate 10.1. Ano ba itong 10.1 na yan? Actually guys, no, ang ibig sabihin examiner dyan is that 10.1 kilonewton, that would be the weight ng ating course aggregate per cubic meter of our mix, no? So ano man yan? So you'll have here 10.1, no? 10.1 kN per cubic meter. And if you want to get the weight, anong gagawin? Multiply mo ng volume, which is 1 cubic meter, no? Sa ating ginawa dito. And then, specific gravity sa baba, you have here, specific gravity of course aggregate, you have 2.68. Okay? And then times your gamma water, which is naka-kN man yan, so you must use 9.81 kN per cubic meter for your unit weight of water. So again, na dapat consistent ka, anong unit sa taas, dapat yun gamitin sa baba. So let's operate this. You have 10.1 times 1, so kung nilagay, then you have 2.68 times 9.81. You will get 0.384 cubic meter. So ito po yung ating volume ng porous aggregate sa isang cubic meter. 384 cubic meter. Ayan. So for our last part here, no, to answer number 10, volume ng ating entrap air. Ano sinabi sa problem? Yung entrap air natin is 1%. Percent of what? Diba pag sinabi kasing percent guys, it is a fraction of something. So walang sinabi guys no, in terms of what. So technically, that is percent of this 1 cubic na ginagawa natin na concrete batch. So 1% of 1 cubic, ano man yan? That is 0.01 cubic meters. You add everything, so you have here no, 0.18 plus 0.119 plus 0.384 plus 0.01. You will get here a value of, this one, 0.693 cubic meters. Okay, so this would be your answer for number 10. So that would be letter D. So, ito guys, no, i-continue ko lang konti ha, hindi tinatanong sa problem. Itong 0.693, that is composed of your water, cement, porous aggregate, and air. So, if you conduct 1 minus 0.693, ang lalabas po na volume dito, kaya gawin natin, 1 minus answer. Ang lalabas po na volume dyan na 0.307 cubic meters, ito po yung gagamitin natin na volume for our fine aggregate. So, yan po yung concept dito sa ating ACI method. Number 11, for 10 cubic meters of concrete, how much cement is needed? But be careful guys, no, hindi po bags ang tinatanong ha, how much cement in kilonewton is needed? No, medyo tricky sa examiner, no? So, be careful. Di ba kanina, nung nasolve natin, ginawa 1 cubic meter ang proportioning natin, no? We have here 300, look at the lower left sa screen natin, we have 375 kilograms, no, from our water cement ratio. Kasi itong 180 kilograms ng tubig, that is for 1 cubic meter ng concrete mix natin. Therefore, we will use 375 kilograms of cement per cubic meter of your concrete. So, you know, kaya natin. So, you have here 375 kilograms cement per 1 cubic meters of concrete. Okay, yan po yung nakuha natin na data kanina. So, ang gagawin lang po natin, no, itong 375, no, 375 kilograms of cement per 1 cubic meters of concrete. If gusto mo ng kilograms of cement, no, si weight ang hinahanap natin, malamang you will multiply this to the volume of your concrete, which is 10 cubic meters concrete, no? If you do that, ano mangyari dito? Ito cancel yan, di ba? So matitira, that is in kilograms of cement. So 375 times 10, you have 3,750 kilograms of cement. But again, hindi pa yan sagot kasi ito nakamass pa po yan. So if you want this to be in weight, kasi which is kN na yung hinahanap, you need to multiply this by 9.81, no, acceleration ng gravity. And after multiplying by 9.81, lalabas dyan, naka-newton pa po yan. So divide mo pa ng 1,000. Okay, para yung newton maging kilonewton. So now you have here 3,750 times 9.81 all over 1,000. You will get here 36.78 or 36.8 no, kilonewton based sa ating answer, sa ating choices. You have their letter C. Then for the last item for this situation, number 12, if the combined solid volume of cement, water, coarse aggregate, and entrap air is 0.55, what weight of dry sand is required? Ang given sa atin ngayon is yung volume ng semento, tubig, coarse aggregate, and entrap air. Diba? Yan yung ginawa natin kanina sa may taas, no? Getting that volume D. Okay? You have there 0.55 na yun daw. So ito yung beauty minsan sa mga tanong examiner. Kasi supposedly in a situational problem, anong data mo sa mga previous item, yun yung gamitin mo sa next items, no? So if magkamali ka sa first item or sa mga previous item, there's a good chance na mali ka rin sa ating succeeding items, diba? So chain effect po yan. Pero medyo mabayad din sa examiner kasi may times na gumagamit siya ng ganitong scenario. Kung saan, supposedly may data tayo for the combined volume na yan, pero in this problem, siya mismo nagsabi na, ito, 0.55, ito muna gamitin mo. So therefore, nagkamali ka man sa ating number 10, pwede ka pang makasagot sa number 12, basta alam mo yung prinsipyo or yung principle of the problem. Yung volume na yan, that's 0.55, therefore, ano yung volume ng ating fine aggregate? Diba, if you recall kanina, itong 0.55 na yan, that is cement, water, coarse aggregate, and air. Anong kulang dyan para maging 1 cubic meter, that would be the volume of your fine aggregate. So that would be 1 minus 0.55. So that would be 0.45 cubic meters. Volume yan. Pero guys, ang tanong sa atin, hindi volume ng sand or dry sand. Hindi po volume, but rather weight po yung tinatanong sa ating sand. So how do we get the weight? So, tandaan nyo yung ginawa natin pagkuha ng volume kanina, diba? That is volume is equal to weight over gamma, or you have your weight over specific gravity times gamma water. So right now, may volume ka, pasok mo yan dito, so that you can calculate the weight. Okay? So you have your 0.45 cubic meters equal to unknown na weight, specific gravity ng fine aggregate or sand, you have there 2.64, then anong gamma of water gamitin natin? So it will depend sa anong gusto mo na unit yung lalabas sa weight. If you want it in kilograms, ang lalabas o dapat gamitin na gamma ng water would be yung density na 1,000 kg per cubic meter. But if you want it in kilonewton, you must use here a value of 9.81 kN per cubic meter. In which ito yung gamitin natin. So yung may observe guys no, sa board exam, hindi po binigay anong unit ang weight dito na sa ating number 12. So, para siguro, no, ang gusto siguro mangyari dito, sa gumawa ng tanong, is baka naka-kilonewtons. Kasi guys, from the previous item, kilonewtons yung ginamit for the weight na part. Most likely, baka kilonewtons rin dito, no? So, in case, no, na you'll encounter the same situation sa board exam, For example, pag solve mo, anong unit man to. I-check mo muna, you try to guess anong unit. Solve it, pag wala sa choices, just convert it to other units. Yun lang po gawin natin, okay? So let's do it. Weight is equal to, let's operate this. You have 0.45 times 2.64. Again, transpose ko lang sa kabila ha. Para diretso na, 2.64, then 9.81. You will get here 11.654. That is in kilonewton. So yung sagot po natin number 2, that would be letter D. The bill of quantities is to be prepared for a 14 square isolated footing with length, width, and thickness of 1.2 by 1.2 by 0.3 with depth of 1.5. The footing supports column with dimension 0.4 by 0.4. The foundation is strong enough that formwork is not required for footing. Provide 100 mm thick compacted gravel, soil factor for backfill is 1.15%, and unit weight of steel is 7,860 kg per cubic meter. Number 13. Determine the nearest quantity of excavation in cubic meter. So, of course, now when we do our excavation, ipa-follow natin yan sa ating size ng ating footing, no? So, pag tingin tayo top view, if that is 1.2 by 1.2, yan yung hukayin natin, di ba? So, sabi sa problem, may depth daw tayo, yung footing daw natin mas rest on a depth of 1.5. Pero guys, take note, may sinabi yung problem na provide 100 mm thick compacted gravel bedding. So therefore, if 1.5 meters yung ating depth, you must add additional 100 mm here, or that's 0.1 meters for the gravel bed. Tsaka magsisimula yung ating footing. Okay, kasi guys, when you mention i-depth doon sa ating footing detail, no, or sa ating, meron tayo sa ating plano, 1.5 na depth na yan, that is measured from your top, no, sa lupa, papunta sa bottom ng footing. So therefore guys, yung hukayin pala natin is from the soil ground papunta sa bottom talaga sa ating hukay, that would be a total of 1.6 meters. So yung volume natin ng excavation, that would be area ng ating footing 1.2 by 1.2, then times our total depth na 1.6. So itong ginawa natin, no, this is good for one footing pa. Din sinabi sa problem man, 14 square footings man, di ba? 14. So ito, times 14 pa natin yan. So you have here 1.2 by 1.2 by 1.6 by 14. You will get here 32.256 cubic meter. So that will be letter A. So ito po yung sagot natin, number 13. So next item tayo. Determine the nearest volume of compacted gravel. So again, yung gravel kanina, may thickness yun na 100 mm. Of course, yung area niya dyan, it will follow the 1.2 by 1.2 sa ating footing, di ba? So volume ng ating gravel, no, that would be area na 1.2 by 1.2, thickness niya na 0.1 meters, and then we have 14 footings. So ito na, palitan lang natin ito ng 0.1 para mabilis. You'll have 2.016 cubic meters. So that would be letter D. So next item tayo. Determine the nearest volume of backfill in cubic meter. So ito muna guys ha. After natin maghukay, magbuhos ka ng footing mo, then of course no, before ka mag-backfill, of course no, patapusin mo muna yung column mo. So itong part no, na may space dito, of course no, we will put the backfill here. So tingin natin sa top view dyan, no, may column tayo na 0.4 by 0.4, and surrounding it, no, may backfill na lupa. So ang tanong sa atin is, ano po yung volume niyan for the 14 isolated footings na yan? So ang gawin natin guys, no, yung gawin no, this is 1.2 by 1.2. You get the total area, then you subtract this one. You will get this area dito no, sa ating backfill. After that, you multiply it to your height here. After doing that, multiply mo ilang footing meron ka, you will get the total volume of backfill. But be careful, may binigay dito ng swell factor for backfill which is 115%. So ano ba swell factor? So actually no, pag maghukay ka, di ba medyo consolidated normal yung lupa natin, no, pag maghukay ka, ma-disturb yung ating lupa. So parang mag-swell po yan, parang bilobo. So when you backfill it, no, you will increase that volume no, to account for that swelling. Okay, yan po yung ibig sabihin yan. Sige now, so let's operate this. Yung volume ng backfill natin, that would be, first yung area natin, that would be 1.2 by 1.2, subtract natin yung sa inoccupy ng column, that's 0.4 by 0.4. Then after that, multiply natin yan sa height. Di ba sabi sa problem, yung depth natin is 1.5, then thickness ng ating footing, that's 0.3, so malamang this is 1.2. So you have your 1.2 meters, then multiply natin sa ilang pieces meron tayo, we have 14 footings. So yan guys, na-operate natin. 1.2, square lang natin guys, para mabilis. Then you have 0.4 square, then times 1.2 na depth times 14 pieces. You will get 21.504. But be careful ha. So 21.504, be careful sa choices din yan. So be careful ha. Kasi we need to multiply first the swell factor na para makuha yung final answer. So ito guys, na multiply pa to ng 1.15, or we have 15% na swell no. So 1.15 times answer, you will get 24.7296, or that's 7.3 na round off natin. So that would be your answer for number 15, and that is letter A. So next item po tayo. Determine the nearest quantity of concrete for the footings in cubic meter. So pag footing lang pinag-uusapan, no? So we have 14 na 1.2 by 1.2 by 0.3, so easy breezy. So volume concrete. So technically this no, pag nag-estimate tayo most of the time, this is just basic na mathematics no. So we have your area 1.2 by 1.2, thickness of 0.3, and we have 14 pieces. Okay, let's operate this. 1.2 by 0.3 by 14. You will get 6.048 cubic meters of concrete. So this would be letter C. Okay? So after meron ka ng volume ng concrete guys, no, ng yung structural member, ito na rin gagamitin mo ngayon for you to know ilan yung cement needed, ilan yung volume ng sand, ilan yung volume ng gravel. So ano yung na-learn nyo kanina sa ating previous 3 situation, depende na lang anong method gamitin mo. Yun po ay yung gamitin natin so that you can obtain these quantities here. So if hindi ka naman mag-manual na batching, hindi ka mag-manual mixing, if mag-order ka ng ready mix, you don't need to do this. No, diretso ka na dito, order mo na yan. A concrete slab is to be constructed with a clear dimension of 4.5 by 7. So, mayroon na tayong 4.5 by 7, no? Kaya yun na yung drawing pero hindi yung proportion. Well, of course, may beam or supporting members din yan. So, ang sinabing clear guys, no, yung clear span talaga ng slab natin, no? Yan po yung given sa atin. So, number 1, which of the following most nearly gives the quantity of standard plywood needed for the formworks? So, of course, yung formworks ng ating slab, diretso lang yan sa baba, no? Yung plywood natin. But in the first place, ano ba yung standard dimension ng ating plywood? So, that is actually 4 feet by 8 feet, or that is actually 1.2 meters by 2.4 meters. Yung iba guys na ginagawa in finding the quantity, ginagawa nila ganito. They obtain the area ng ating slab, then i-divide lang nila ng 1.2 by 2.4. You can also do this as an estimate lang, estimate, no, approximation lang man. So you have your 7 by 4.5 na area ng slab over 1.2 by 2.4 na area ng isang plywood. This will give you around 10.93, no? And you notice ating choices, wala pong ganyan. So let's try to think, no? Yung 10.93 na yan, bakit wala sa choices, no? So ganito kasi this, no? So i-recreate ko lang yung drawing ko, gawin ko siyang proportional para klaro. Let's say na isang box sa background natin is 1 meter, yan siya 1, 2, 3, 4, and 4.5. 1, 2, 3, 4, 5, 6, 7. Okay, so ito po yung ating clear dimension ng ating slab. And then may plywood tayo 1.2 by 2.4. So let's say no, ito yung 2.4 natin, no? 1.2 malamang nandito yan. 2.4 malamang ito yan. Okay, ganyan. Isang plywood yan, another plywood. So recall guys, no, na ating dimension 4.5 lang yan, ito 7 meters. So pag kinonect mo tong dalawang 2.4, ano mangyari? You will get 4.8. So technically naman sobra ka dito. Okay? Then you do it again, no? And I believe no, you will have here 7 over 1.2 kasi 1.2 po yung part na to sa ating plywood. You will get here 5 plus may sobra, no? So technically 6 po yan, no? So you have your 1, 2, 3, 4, 5, 5, then 6. Maybe ganyan siya, no? So 1, 2, 3, 4, 5, 6, 5.83. Kasi guys, when you do 5 times 1.2, that is 6 lang. Kung 5 plywood lang dito, yung paritong direction, if 5 lang, that's 6 meters, kulang pa ng 1 meter. So may part ka dito sa dulo na 1 meter lang yung ginamit, and the rest is sobra na. So if you do it like this guys, no, yung pag-estimate nyo using area na projection, you will notice na ilan kailangan nyo. You have 1, 2, 3, 4, 5, 6. Then times 2, you have 12. You actually need 12 pieces, no? If assuming na i-waste mo yung mga sobra dito. Well, actually this, no? In construction estimate, ito yung mas favorable na pag-estimate. Kasi no, of course, may extra kami allowance ka. Mas maganda yun para hindi ka magkulang sa actual site. Well, if medyo kuripot ka, gusto mo talagang zero waste, no? 100% efficiency, no? Which is hindi naman nangyari. Pwede mo itong gamitin actually, no? Pwede mo yung gamitin, no? Pantapak mo, if you use 11 lang, no? 11 pieces. So, 1, 2, 3, 4, 5, 10 na yan. Yung kulang na part dito, na itapak mo itong lahat ng wastage na dyan. Pwede man, pero medyo hassle na yan no, sa mga tao nyo. Hassle na rin yan sa framing part, no? Yung support ng kahoy sa baba. So, hindi na yan conducive, no? In the construction. That's why, no? Our answer for number 1, that would be letter A. No? We will use 12 from this area projection approach. And guys, this very example, this is actually good, no? Na-visualize nyo na kasi pagdating sa tiles, no? Although lang tiles sa sample natin, bro, same concept, pagdating sa tiles, same din nangyayari. Kasi when you cut your tiles, you cannot just do something like this, no? Na area over area ng tiles, you know, yung pieces. Kasi may part kasi na may factor yung pag-cut mo na hindi mo na ma-recycle yung part na yun. Like this one, no? Ito actually pwede recycle. Pero pagdating sa tiles, no, medyo pangit na marami kang recycle dyan, maraming cuttings, no? Unless part siya ng design. So yan po yung i-consider nyo guys na when you do your actual estimate. Well, if ayaw mo na sakit ng ulo, ayaw mo na mag-drawing ng ganito, usually ginagawa, they do something like this, and then dagdag lang sila ng percentage for the wastage para ma-cover yung mga hindi na consider no na parts here, like this one, yung waste na sana ginamit pa pala sa area, ma-cover na yan ng wastage na yan. Okay, so wastage, ako I use 5% for my estimate, yung iba naman 10, depende no, depende sa anong trip nyo. So proceed tayo next item. If 286.65 board feet is needed for the wood frame of the slab formworks, what is the total length in feet if the 2 by 3 inches wood is used? Okay guys, when you estimate timber or yung kahoy natin, that is in board feet. Yung isang board feet guys, no, that is composed of 12 inches by 12 inches by 1 inch na thickness na kahoy, no, that's board feet in volume. Or actually kinukuha natin yan ng ganito. So you get the width niya in inches, multiply mo siya sa kanyang depth in inches, then you multiply it sa kanyang length in feet. Then you divide this by 12, you will get something in board feet. Okay? Kasi guys, no, when we buy our timber no, sa ating hardware, board feet po yan yung quantity. No? So, based sa ating problem, we will need daw 286 board feet. So, may quantity na. 86.65 board feet. So, ang question ngayon, ano daw yung length, total length na gagamitin natin if we are using a size 2 by 3? So, technically, no, yung length yung unknown, you have here 2 inch by 3 inch over 12. So, ano natin L dito, ang dapat si L ang lalabas dito, naka-fit na po yan. So, sige na, shift solve natin to. You have 2 by 3 by x na unknown over 12 is equals to 286.65. This will give us an answer of length na 573.3 feet. Okay, so yan po yung total na kahoy na kailangan natin for this problem. That's letter D. Okay, 573.3. Sige na, proceed to the next item. If the concrete slab is to be reinforced by 12 mm diameter bar, what thickness of concrete spacer for the bottom bars must be prepared prior to concrete pouring? Ano man itong concrete spacer, no? In reality, no, although diba sa ating section ng slab, we put here concrete cover, diba? Okay, naglagay tayo concrete cover, which is a slab that's 20 mm. But in reality, no, paano mo mapalutaw yung bakal na yun na hindi siya mag-touch sa ating formworks? Kasi guys, no, pag hindi ka maglagay ng spacer dyan, ano mangyari? Yung ating rebar, it will touch on the formworks. Pag buhos nyo, ano mangyari? Wala po yung band, no, with the concrete is exposed yung other side. That is actually dangerous. So, dapat po tayo magawa ng spacer, no? So, hindi man yan expensive, no? Kuha ka lang ng mga lata, okay, cut mo yan, or ang ginagawa namin, no, bili kami isang PVC, okay, cut namin, no, by the thickness na gusto namin, yung lagyan ng concrete, then, lagyan ng cut ng PVC, lagyan ng concrete, then lagyan ng tie wire, mga ganyan. Para pag ma-harden na yan, dyan mo ipapatong ngayon yung rebar mo. So, for the slab, the thickness must be 20 mm. Kasi yan yung ating cover, no, ng ating slab. Pag yung ating spacer naman ay gagamitin para sa column, okay, malamang, ang gagamitin mo must be 40, kasi 40 mm yung ating concrete cover, diba? So, depende sa structural member, guys, this is under na sa ACI na, ano, requirement. Kasi sa NCP man to, concrete cover requirement. So, for number 3, your answer must be letter A, 20 mm. Given the plan of the guardhouse shown, the height measures 3 meters measured from finished floor level. The CHB on the window wall is only up to 9.9 meters, and the wall beside the door opening is only up to 2.1 meters. A fixed glass was placed on the remaining 0.1 meter na height. Hollow blocks measures 100 by 200 by 400 mm. Concrete slab rests on a 100 mm gravel bed. Number 4, determine the number of hollow blocks to be used for the project. So actually, this na yung hollow blocks po natin. May dimension po yan, standard dimension. 0.2 yung height, and then you have 0.4 na length. And then yung thickness niyan, magdepende na yan if 6 inch ka ba na variant or 4 inch. And yung sikat na 6 and 4. Normally, we use 6 inches for external na wall and then 4 sa loob. Pero pag maliit yung structure mo, ginagawa ng iba 4 inches, no, ginagamit. For example, like this guardhouse, ginamit sa sample sa problem is 100 mm, that's 4 inches. So tanong sa atin guys, determine the number of hollow blocks to be used for the project. So, ito guys, ang gawin natin, kuha muna tayo ng 1 square meter. That's 1 by 1. Then let's count ilang hollow blocks ba meron tayo sa isang 1 square meter na area. So that would be 1 meter over 0.4 by 0.2. So gawin natin yan, 1 over 0.2 by 0.4. You will get 12.5 pieces. Actually guys, no, pag i-plot mo yan, if gagamitin mo yung buong 1 meter na mayroong 0.4 by 0.2, may part dyan sa ating 1 meter na nakatayo na yung hollow blocks, no, if you do that, no, if you try to draw it by area. Pero guys, no, this is a very acceptable na value for 1 square meter, 12.5 pieces. It's because, no, hindi pa natin na-account yung mortar sa gitna nila, no, mga mortar pa yan. So technically, you will need less number of pieces sa ating 12.5. So by using 12.5, may factor of safety ka na kasi hindi pa na-account yung thickness ng mga mortar. Okay, so it's safe na hindi ka na magkukulang dyan. So if that's our needed na CHB for 1 square meter, no, ang gawin natin, we need to know ano yung total area ng ating hollow blocks. So let's try to draw this in 3D. Ano yung ating structure? So let's say ito yung poste natin, no? Meron kang 0.9 na height dito, no? Ito po yung 0.9. May bintana daw dyan. Then you have door ito. Okay, dito may door ka. And then, after your stiffener footing, stiffener column, may wall ka dyan. May wall ka dyan, ganyan. And then ito, window to, fixed window. This is another fixed window. Then, itong i-blue ko guys, ito yung wall natin. This one wall yan. Ito wall yan. Itong sa bottom wall, then wall din yan. Okay? So, yan po yung areas natin. So let's start with sa likod. Okay, 2 meters yung ating length, no, external yung dimension ng external yan. And then yung ating stiffener column, that's 200 by 200. So therefore, this free length here, that's 200, ay 2 meters minus 2.2. Or technically, that is 1.6. So 2 meters to, 0.2 yung column, technically 1.6 din yan. Okay, so puro 1.6 na, except for this 1.8 yan. So let's start with this area 1. So area 1, you have there 1.6 na width, and then yung height niya, length. Yung height niya dito is 3 meters na buong wall po yan. Area 2, you have there, let's say ito yung area 2, itong dalawang yan. So that's 2 times. Yung length niya, 1.6 pa rin. Pero yung height niya, sabi sa problem kasi, may window tayo at it will start 0.9 from the finished floor level. So yung wall natin dyan, ito, 0.9 lang yan. So you have your 0.9. And then lastly, area 3, itong katabi ng ating door, no? So, isa lang po yan, then may height itong, ay may width, may length itong 0.8. And then anong height niya? So, nagkamali lang ako ng hindi 2.9, no, it's not 0.9. Kasi, sabi sa problem, a wall beside the door opening is only up to 2.1. So, height pala ito is 2.1 meters, no? Wall yan. Okay, so, may open space or window sa part sa taas niya, no? So, yung wall is may height na 2.1 lang, so you multiply this by 2.1. That is your total area. Okay, now, so let's get that one, no? Calculate natin. You have 1.6 times 3 plus dalawang 1.6 times 0.9. Then plus 0.8 by 2.1. You will get a total area of 9.36 square meters. After having this, if you want to know the number of hollow blocks needed, no, that would be yung 12.5 pieces, no, per square meter, multiply mo lang yan ng 9.36 square meters. So, canceling square meter, you will get in pieces. Times 12.5, you will get here 117 pieces. So, of course, no, supposedly, in actual estimate, after having the exact quantity, mag-a-add ka pa ng wastage, no, para sure na hindi ka magkulang sa cycle. Anyway, wala mang sinabi sa problem, no, anong wastage gagamitin. So, let's assume na ito na yung sagot natin, and that would be letter A. Determine the volume in cubic meter of the plaster on the wall if the thickness is 15 mm. Include the plaster at the top of the wall. So, bali guys, no, aside sa ating lateral na area, pinapasali sa atin yung pag-plaster dito sa ating taas, no. Of course, ipaplaster natin yan. Before ka maglagay ng window, magpa-plaster ka muna, no, para smooth yung finish natin. So, first, kunin natin yung total area. So, diba yung area natin, area 1, 2, and 3, no, itong nakuha natin dito, that is 9.36. Then yung mga lateral area. That's the area here, here, and here. Pero guys, that area, isang side lang yan. So, we need to do times 2 of that para masali yung sa likod, no, kasi plaster naman yan. So, you have there 9.36 times 2, yung area to total. Aside from that, you need to get the area sa taas, no, kasi pa-plaster din natin yan, no, yung taas, no, before tayo mag-window, pa-plaster din yan. So, we need to get the total length first. So, you have 0.6, itong clear meter, di ba, 1.6 yan. Ito, 1.6 rin, di ba? So, tatlong 1.6, no, yung length natin, that's 0.8 plus tatlong 1.6, yung length yan. To get area, multiply mo ng width. So, anong width natin? Ang ating CHB may thickness na 100 mm. So, pag 100 mm tong ating CHB guys, no, if we apply our plaster na 15 mm, ano yung ating total width ngayon? So, that's 100 plus dalawang 15, or that is 130 mm. So, yan na ngayon yung bagong width mo sa wall mo, no? So, that would be 0.13 meters, no, 130 mm. So, that's the total area ng ating plaster, no? So, you have 9.36, no? Yan yung area na solve kanina, no? This one, no? 9.36. Then, times 2, kasi likod siya kaharap. Then, plus, yung length natin, no? 0.8 plus tatlong 1.6 times 0.13 na width. You will get 19.448 square meter. You get that, no? Pero guys, area yan. Ang tanong sa atin, ano yung volume ng ating plaster? And the plaster has a thickness of 15 mm. So, if you want to get the volume ng plaster, anong gagawin lang? That's area, multiply mo ng thickness, which is 0.015 meters. So, gawin natin yan, 0.015. You will get 0.29 cubic meters. Or, sa ating choices na if you check na walang 0.29, probably the closest answer for this rounded up siguro, 0.3 cubic meters. Okay, and that is letter A. A 4 meter length pipe having a diameter of 600 mm is to be installed in 1 hour at a cost of 570 pesos per meter. One foreman has a rate of 50 pesos per hour, 2 skilled laborers have a rate of 40 pesos per hour, and 10 unskilled laborers have a rate of 35 pesos per hour. A backhoe was rented for 800 pesos per hour, and a compactor was rented at a rate of 120 pesos per hour. The volume cement needed per meter length is 0.07 cubic meter at 130 pesos. No, in sa sand, you have 0.15 cubic meter at 300 pesos per cubic meter. And we have here VAT 10%, and then insurance 30% of the equipment and material cost. Which the following gives the total cost of labor and equipment per meter length of pipe. So before we start this, let's tackle muna yung project cost natin. Okay, within the project cost, ano ba meron dyan? Meron tayong two parts. We have the direct cost and then the indirect cost. Sa direct cost is, no, dito makover natin yung materials natin, no, yung ating equipment na ginamit, no, and then yung ating labor. Anything aside from that, that is considered as indirect. So, ano example dyan? So, sa problem natin, you have there the VAT, you have the insurance, etc. Okay, no? Anything hindi kasali sa material, labor, equipment, indirect cost po yan. Upon knowing that, no, extra knowledge lang, upon knowing that, in this problem, tinatanong sa atin, ano daw yung total cost of the labor and equipment. So, that is the two part ng ating direct cost, no? So, be careful guys, kasi ang tanong sa atin dito, ang cost ay in terms of per meter length of pipe. Per meter length of pipe, no, ang costing. So, let's check na ba meron cost, anong costing ba meron tayo? Let's start with the labor. Yung labor natin, no, meron tayong foreman, rate niya is 50 pesos per hour, di ba? And then you have dalawang skilled labor, no? Skilled labor, no? This is dalawang 40 pesos per hour. And then you have unskilled labor, or that is our helper, no? Unskilled labor, that is 10, 35 pesos per hour. Okay? If you total the labor cost, guys, no? That will be 50 plus 240 plus 10, 35. You will get here 40, 80 pesos per hour, no? That is for the labor cost. Ngayon guys, hindi man pesos per hour ang tanong sa atin. Ang tinatanong, ano yung cost per meter length ng pipe? So dito ngayon papasok yung ating productivity. Okay, we'll use this one, productivity. So productivity na, this is just no, ano yung trabaho natin at a certain period. So sabi sa problem, a 600 mm diameter pipe is to be installed in 1 hour. Okay, a 4 meter length pipe is to be installed in 1 hour. So ano magagawa mo dyan? So you can do a productivity rate na 4 meters per hour. Okay, so ano significance niyan? Kasi guys, you will need this to have an answer na cost per meter length of the pipe. Okay, so gawin natin, no? Itong labor cost natin na 480 pesos per hour, ang gawin natin, no? We divide this by the productivity rate na 4 meters per hour. If you do that, no? If you do that one, cancel yung per hour, ano matitira? You will get pesos per meter. But that's actually cost per meter length of the pipe. Okay, yan yung hinahanap sa problem. So if you do that, 480 over 4, that is 120 pesos per meter, di ba? So, may isang part na tayo, no? Sa labor pa lang yan, guys, ha? Sige, no, let's store this sa variable A para magamit natin later. Next, kuha naman tayo sa ating equipment cost. Ano ba meron tayo dito? May backhoe tayo, rented at, no? Mag-rent tayo nito at 800 pesos per hour. And then we have a compactor at a price of 120 pesos per hour. So if you add this up, you will get 920 pesos per hour. And again, no, anong meron tayo? That is pesos per hour, and we want in pesos per meter. So again, we will use the productivity na 4 meters per hour para ma-convert po natin yan. So cancel yung per hour, and you will get here 920 over 4, you will get 230 pesos. So ito yung ating equipment cost. So pa-store na ito kay variable B, no, para magamit later, no. So right now, ang sagot natin, that is A plus B, di ba? You add this two, no, sagot natin, no, for this one, that is nakastore sa A plus nakastore sa B, you will get 350 pesos, no, per meter. And that is letter B sa ating choices. Sige, no, proceed tayo next item. Which of the following gives it cost of material per meter length of the pipe? You have here, yung ating pipe daw, it cost 570 pesos per meter, no? Yung pipe mismo ito. But aside from the pipe, we also need the volume ng cement, which is, no, kailangan natin ng 130 pesos per cubic meter. And in 1 meter length, we have 0.7 cubic meter. Okay, so therefore, no, cement, ang gawin mo lang, that is 130 pesos per cubic meter. And then, you have 0.07 cubic meter sa isang meter length. So, ano mangyari? Cancel yung cubic meter, you'll have your 0.07 per meter. Multiply mo dito, you'll have pesos per meter. Okay, yun yun. And then aside from that, you have sa ating sand, that is 300 pesos per cubic meter, and then in 1 meter length, you will need 0.15 cubic meter. Okay, so same idea kanina, cancel to, and you will get pesos per meter. And then lastly, ang gawin lang natin is you just add everything. So sige na, calculate natin guys. This will give you an answer of 624.1 pesos per meter. So ito po yung cost ng ating materialis, no? That is letter A. So sige na, pa-store natin to sa variable C. Okay? So ngayon, proceed tayo number 9. Which of the following gives the total cost of project per meter length of pipe? So total cost yung tanong guys, ha? Total cost. And again, the total cost of the project, no? That is composed of your direct cost plus indirect cost natin. So yung direct cost natin, ito yung nakastore sa A, B, and C. Ang recap ko lang, yung nakastore sa A, ito yung labor cost. Nakastore sa B, ito yung equipment cost. And then nakastore sa C, ito yung material cost, di ba? And then aside from that, aside from the direct cost, you also have indirect cost, which is yung BAT na sinabi sa problem, is 10% of your equipment, labor, and material. So that is A plus B plus C. And aside from that, you have 30% for the insurance ng ating equipment and materials. So equipment, that is nakastore sa B, materials nakastore sa C. So you add this up, no, you will get the total project cost. So well, technically this, no, itong part na to, this one here, no, umulit lang man yan. You can write it as like this, no, that would be A plus B plus C, no, common term yan. Then palabas mo, you'll have your 1 plus 0.10. Okay, you can also write it like that para mabilis. And then you have the 30% of B plus C. You will get here a total cost of, okay, per meter length to guys, ha, total cost per meter length of 1327.74 pesos per meter. Ito po yung sagot natin, no, and that would be letter C.